Good morning, my dear students, and welcome back. Today we will focus on how to answer some of the exercises in your Module 5 and 6. Let's take a look again at your module. This one is Module 5, Infer the relationship between current and voltage. Then here is your Module 6, Infer the relationship between current and voltage. So that competency is split into 2 weeks. And as I said a while ago, we will focus on showing you the solutions to some of the exercises there. Example is this one. Okay, so let's begin. Now, take a look at activity 4. You are being asked there to solve the set of problems using the relationship between charge and current. Since current is the amount of charge passing through a point, then you will have more current if you have more charge. So this is what you mean by this equation. Current is equal to charge per time. I here is current and the unit is ampere. The symbol of that is A. The Q means charge and the unit is coulomb or C. And of course T is time in seconds. You are also given a mnemonic to remember the relationship using this triangle. How do you use this formula triangle? If you are looking for current or I, which is this one, then just cover that part. So you are left with Q that is divided by time. Do you see this one? Q over time. And that's it. That is your equation for current. If you are looking for time, then just cover T in your triangle. Then you are left with a Q that is divided by an I. So that is your equation for T. Similarly, if you are looking for Q, just cover Q in your triangle. Then you are left with an I that is multiplied by the T. So that is your equation for Q. Another important information that you need to consider is the accuracy of your units. Using this equation, that current is equal to charge divided by time, it gives the relationship among the units. Current is ampere, charge is coulomb, and time is in seconds. This tells us that 1 ampere is equivalent to 1 coulomb per second. Let's try the first problem. The first problem is this. The designer of this test is generous on time to provide a circuit diagram. This is the symbol for the bulb. Here is the power source. That is the symbol for the battery. And also you have a switch here. If you flip this switch, you will have a closed circuit, a loop for current to flow through. So let's get to it. A current of 2 amperes flows through a bulb in 3 minutes. Calculate the charge that passes through the bulb in that time. Let's recall the relationships among these variables. These 3. You may also use the formula triangle. The problem statement provides us with a current, so let's write that. I is 2 ampere, or 2A. It also says time is 3 minutes, so let's write that down as 3 minutes and then put that in seconds. Each minute is 60 seconds, so 3 of that, so you have 180 seconds. We are looking for charge, so let's also put that in symbol. Q is the unknown. Of the equations that we have here on this left side, this one will give us the answer. Charge is the product of current and time. Let's replace I with 2 amperes, then the time with 180 seconds. And then remember that ampere is equal to coulomb divided by second. With that, we can cancel second. We are left with C or coulomb as the unit. So the charge is 360 coulombs. The next 2 examples are too similar in the process to this one. So I'll stay quiet now while I show you how it is done. That's it. We have completed activity 4. Should you find any part there that is confusing, you may take a screenshot of that portion and send it to me for clarification, okay? Now let's take a look at activity 7. Activity 7 is asking you to evaluate the relationships among the three variables as indicated in this formula triangle. At this level, it is helpful, but I don't think as you progress in your study, you would appreciate equations written in that form. Anyway, V here is voltage, the unit is volt, and written as V. I is current, and the unit is ampere, written as A. Then R is the resistance, unit is ohm, written in the Greek letter omega. Let's see. Using the triangle, if you are looking for R, just cover it, and you are left with V divided by I. If you are looking for V, cover it in the triangle, so you get I multiplied by R. Do you see this? I multiplied by R. If you are looking for I, just cover it, then you have V divided by R. V over R. Okay, so we have the three equations already. Now, let's inspect the units using this equation. R is equal to V divided by I. The unit for resistance is ohm, so voltage is volts, for current is ampere. So this tells us that an ohm is equal to 1 volt per ampere. Okay, so let's try it. The first problem is this. What current flows through a hairdryer plugged into a 110 volt circuit if it has a resistance of 25 ohms? Okay, before we do anything, let's pull up our equations. This 3. Let's inspect the problem now. It is looking for a current. What current? That gives away equation 3, this one. Then it also gives us the voltage, 110 volts. Let's write it here. Then the resistance, it says 25 ohms. Let's put it here. Then we are left with current as a blank. Okay, let's find current. Current is equal to voltage divided by resistance, this equation. Let's substitute the numbers on the symbols. Voltage is 110 volts. And resistance is 25 ohms. This gives us 4.4 amperes. Let's fill up that blank. Okay, that's it. Beautiful. There are still 4 very similar examples. I'll leave you with some music as you watch me demonstrate how they are solved. You may pause or reduce playback speed to match your pace. Okay? Let's begin. That's it, guys. I hope you learned something from this video. Do not hesitate to message me for your questions. Thank you and bye.